Hello everyone, thanks for tuning in. Today I'll be demonstrating how data scientists can run their compute-intensive machine learning notebook applications on the IBM PowerAI platform. This developer journey is available on GitHub at github.com, IBM PowerAI-notebook. The subject of this journey is evaluating predictability of financial markets using New York Times sentiment and market data. But the real reason, the main purpose of this journey is that it was built for developers familiar with IBM Power Systems that are looking to leverage IBM's new Power AI offering for machine learning. So let's begin by talking about this compute platform. The Power AI systems are accessed via Nimbix, which is a high-performance computing cloud platform. And to promote this offering, IBM has teamed with Nimbix to provide trial accounts that come with up to 10 hours of free processing time on the Power AI platform. The Journey README documents the steps you need to take to register for an account, starting here. This process takes a couple of steps. It's not fully automated, so you need to be patient. The turnaround time typically takes an hour or two, but can take up to a day. The last step in the registration process is an email that's sent to you, which contains a link that you can use to log into Nimbix. And we'll do that right now. We'll go ahead and log in. So this is what you'll see. This is the Nimbix UI. Navigating the Nimbix UI is pretty straightforward. It has two drop-down menus located here and here. The right side sets the mode, and the left side provides options available for the current mode. To get to our notebook demo, let's go to Compute, All Applications, and let's find the TensorFlow example notebook. Let's close this. Here it is, so we'll click on that. Next, we'll click on TensorFlow. So here you can see the server configuration panel, which is set to a very beefy 40-core IBM PowerAI system with 256 gigs of RAM and a GPU accelerator. And of course, if you had a non-trial account, you could select the platform of your choice, obviously paying a higher price for better performance. So the free trial account will just accept the default values and hit submit. So now you'll need to wait a few seconds for the server to power up and be configured. Once it's loaded, you'll see an address and a password appear to access the server. There it is. So we're going to need this password to log in. So let's cut and paste that. Then we'll just hit the click here to connect label. Now it's asking us to log in. The username is Nimbix. Then enter the password that you got in the previous step, So now we see the directory of notebook files. Let's click here to drill down, and then we see our notebook here, the Clean Energy Watson notebook. Click on that. And here is our notebook. So now we can actually talk about the demo itself. So this demo uses Jupyter Notebooks, financial market data, New York Times news articles, Watson natural language understanding from IBM, and TensorFlow for machine learning. The purpose of this demo is to use a Jupyter Notebook to evaluate the predictability of market values in the renewable energy sector by examining related global markets and sentiment detected in New York Times news articles. So a lot of compute-intensive iterations over very large data sets. So let's get started. As most of you know, notebooks run by sequentially running through each of the cells. You can run the entire notebook by selecting cell and run all, or you can run it one cell at a time by selecting the cell and pressing the play button. The tags to the left of the cells indicate its current state. Blank means it hasn't been executed yet. A number represents the relative order that the cell was executed. This 14 just indicates this is a demo. We've run this previously, so it was the 14th cell executed in order. And an asterisk indicates that the cell is currently executing. So let's start the demo. So as you can see, all the cells have already been executed. Feel free when you run this by yourself to go ahead and re-execute these cells. I'm not going to go into great detail about each cell. As I said at the beginning, this journey is more about using the PowerAI platform. But as you go through this, each of the cells is pretty well documented, so you can when you run this on your own, you can dig a little deeper. But I'll go over some of the highlights. So let's see. This cell basically talks about the difference between what this notebook is doing and a similar notebook example provided by Google. The big difference here is the platform, the Power8 systems, and the use of unstructured data that we're pulling in from Watson, New York Times, and some financial data. This cell lists all the global markets that we'll be modeling. You'll see there's a German and an Australian index, a couple of UK indexes, and multiple US indexes. As we move forward, we start to actually execute some code. Start by downloading, installing packages, and then importing some libraries. You see here we use pandas data sets. We use Watson for discovering sentiment. We have matplotlib for graphing, and TensorFlow. So the first thing we're going to do is fetch and merge 3 years of market data. Just as a note, in order to save time and avoid paying for a financial access account, this data was previously fetched and stored in local CSV files to make it easier on you. Next, we fetch New York Times financial news articles from the past 3 years. And again, to avoid having you pay for a New York Times account, this data has already been fetched and stored in a local JSON file. Notice here we're only looking for articles that contain subject matter about alternative and clean energy sources. So next we use the Watson Natural Language Understanding Service to categorize sentiment for each of these news articles. So these articles are going to be classified as either negative or positive. Here's all of our data here. A tail of the data grabbed from the sentiments. Now we began to explore the data. We do analysis on the data. So again, our data consists of a daily list of index closing values. Here's all the indexes at the top, plus sentiment from the New York Times articles. So the first plot, we just plot the index values, but we can see the index values are too widespread. So we divide in each index by its max value, so we get all indexes maxed at 1, which makes for easier reading graphs. Then we replot. And now we can see our first correlation between the indexes. So you can see they all seem to react the same based on the global economic events. So red or positive sentiment results in gains. Green or negative sentiment results in downturns. Um, so during the rest of this analysis phase, we're basically looking for other correlations. For example, here we see a correlation between current index values and lagged values of the same index, especially in the 2 to 400 day range. This tells us the index tend to stay the course in either a positive or a negative trend. The scatter matrix shows a significant correlation between each of the indexes, which indicates that one market can be influenced by another. And so the rest of the cells focus on trying to isolate where the correlations are the strongest. So when we get to the summation, basically our analysis has determined that the Australian index from the same day is a strong predictor for the Nasdaq Energy Index close. We also determined that the European indexes from the same day were a significant predictor for the Nasdaq Energy Index close, and that indexes from previous days were not good predictors for the Nasdaq Energy Index close. So using this as a basis, we then use TensorFlow and the IBM PowerAI machine learning framework to train and test the data. So here's the important piece: the PowerAI now is optimized to support TensorFlow, and that's what we're trying to show here. Is how smoothly they work together. First, we generate and train. We generate our training and test data. Then we run it through TensorFlow. The first model uses a straight binary classification. Notice the iterations and how fast it was able to process them. Then we use the neural network model using hidden layers to add additional capacity to the model. So as you can see, we train multiple models over hundreds of thousands of iterations with checks to see the accuracy of each of the models. And here are the results here. So results are divided into binary classification and the feed forward with the neural network. It looks at financial markets with sentiment analysis and without sentiment analysis. And our best results show a 75% success rate, which means that there's a 75% chance of accurately predicting whether the Nasdaq Energy Index would close up or down on any given day. So after we finish running the demo, it's important to remember to shut down the server. To do this, you need to go back to the Nimbix UI and click on the dashboard current jobs panel. From the detail panel, we just click on the shutdown button here. And then we can log out. So with that concludes the demo and this video. But one last point I want to emphasize, if you're a data scientist running compute-intensive applications with huge data sets, and you're using TensorFlow for machine learning, you should definitely take a look at the PowerAI platform, which is optimized to handle the load. And with the recent collaboration with Nimbix, IBM now makes this platform easy to access and deploy. So hope you enjoyed the video and look for more videos coming out that showcase the IBM Power AI platform. And thanks again for your time.